All right, ladies and gentlemen, today we are going to talk about functions. So when we're talking about functions, we're going to work on the following skills. We need to understand that a function from one set, called the domain, to another set, called the range, assigns to each element of the domain exactly one element of the range. We're going to use function notation, evaluate functions for inputs in their domain, and interpret statements that use function notation in terms of a context. And to do all that, we're going to work on the math practice of constructing viable arguments and critiquing the reasoning of others. So first off, we'll start with some vocab. The first vocab term is the word function, and this is an incredibly important vocabulary term that you'll need to know this year. A function is a relation in which exactly one element of the range is paired with each element of the domain. We're going to practice with this so you see what that means. Each element of the domain. The way we're going to talk about this is we're going to use function notation, a way to name a function defined by an equation. Now, not everything we can describe with an equation is a function, but last year you saw lots of different functions written as linear equations where we had y equals mx plus b. But now what we're going to do, instead of having our output as y, we're going to have our output shown as the function of x using the expression 3x minus 8. Let's keep going here. Next vocab term is discrete function. A discrete function is a graph that consists of points that are not connected. So this is especially important when we're talking about real-world situations. There are some situations, relations that we can model with a graph where it would not make sense to connect the points. An example would be something like if you get an allowance and each month you get $20 into your account, and let's pretend that you never spend any money. So on the first of the month, you get $20, and then the next month, you'll have $40. But it doesn't make sense that halfway through the month, you'll have $30, because we know that that's a discrete function, that it's each month you get money added, not a continuous add. Whereas if you're earning money by babysitting, and let's say you earn $5 an hour, if you work for 1 hour, you get $5, but if you work for an hour and a half, you'll earn $7.50. So that would be an example of a continuous function. A continuous function is a function graph with a line or a smooth curve that passes through all x values with no breaks. And so when we're talking about our continuous functions, we can talk about dots that are connected, whether it's a linear pattern or a nonlinear pattern. Nonlinear is the function with a graph that is not a straight line. So in math, when we use the term line, we mean straight line. And when we're talking about graphs of lines, we're talking about linear functions. That's that y equals mx plus b form that you learned last year. Our last vocab term for today is the vertical line test, and that's a test that we will use to determine if a relation is a function. Make sure that you pause and have all of these vocab terms in your notes. So what we have here are the 4 different ways that we've talked about representing our equations, representing our relations. We have a function shown as a table, as a map, as an equation, and as a graph. So we're going to take those ideas now and we are going to practice. These practice problems, the 4 that are going to appear on this slide, you do not need to copy into your notes, but I want you to pay attention and listen as I talk through them. So what we're going to do is we're going to determine if each relation is a function. Now to do that, we want to think about that definition of a function. A function is a relation in which exactly one element of the range is paired with each element of the domain. So if I look at this one here, each element of the domain is paired with exactly one element in the range. If I look at this value of -1, well, I have both 0 and 4 are partnered with it. But in my domain, with my x values, I see that every x is paired with only one possible y value. So this one is a function. If I were to graph the points, I could see it. If I have -4, -1, -2, let's see, +4, 0, -1, 2, +1, and 4, 4. If I connect the dots here, I got something that looks like this. But I can see that there are no elements of the domain that are partnered with more than one element in the range. Pause for a second. So, next we're going to practice looking at it as order pairs. Well, if I look here, I see a domain value of 2 partnered with a range of 1. But then if I look again, I see a domain of 2 partnered with a range of -2. So this one is not a function because I have my domain is partnered with more than one element in the range. Next one, again, that same idea here. My domain is partnered with 1, domain of 5 partners with 7, but a domain of 6 can either give me a range of 9 or it can give me a range of 10. So if I have 2 arrows coming out of my domain, if my domain can have multiple answers for the range, it is not a function. So this one is another no. Well, this last example here, I have it as a graph, so I'm going to use that idea of the vertical line test to determine if it's a function. And that vertical line test tells me that if I draw a vertical line and I scoot that vertical line along, that I'm only going to ever hit the line at one point. And this one, that answer is yes. I can scoot that vertical line and I only ever touch one point on the graph. It comes close. I have what we'll learn is an asymptote, where it looks like it's going to turn into a straight line, but it never quite does. So I have the first one represents a function, and the fourth one here is a function, but B and C are not functions because I have an element in the domain that partners with more than one element in the range. So for these ones here, I do want you to put them in your notes. I want you to sketch each of these graphs, and we're going to practice using that vertical line test. My vertical line test shows me that if I scoot a vertical line across, I only ever hit the graphed line at one point. And in this case, that's true. This one is a function. This is a quadratic function. But if I do my vertical line test on my next example here, I notice that my vertical line hits 2 points on my graphed line. So this one is not a function. Sometimes when I have a domain value of positive 3, it might have a range of positive 3, or it might have a range of negative 3. This one is not a function. This last one I need to look at carefully. If I draw my vertical lines, I notice that it only hits once. But on the y-axis, I see a closed circle and I see an open circle. Because this circle is open, it tells me that when we are graphing the value of negative, x is negative 2, I would be dealing with this point here. But if I have a y value, or if I have an x value of anything greater than 0, I'm jumping up to this line here. But at this point, there's only one possible value. It's that negative y value. So the answer is yes. This function is not continuous. It jumps, but it has one value for every x. So now we're going to look at some relations that are shown as equations to determine if they are functions or not. And our first one is this equation, 4x equals 8. So before I can do anything, I know that I want to get that x by itself. So to do that, I divide both sides by 4, and I wind up with x equals 2. I've simplified. These are equivalent. But when I look at this here, I find it hard to plug in values. I know that x is 2, and it's my only variable. So I'm going to jump straight to my graph here. Now I know from my skills last year that when I have x equals a number, my graph winds up looking like a vertical line at the point x equals 2. Well, now if I try to do that vertical line test, I can see that when I hit that line, I hit infinitely many points at the same time. So this one is not a function. I can represent this relation as an equation, 2 different equations really, 2 equivalent equations, but it's not a function because it does not pass that vertical line test. So now let's practice with a different one. This one here, I have 4x equals y plus 8. So a similar looking equation here, but now I see 2 variables, so creating a table of values makes sense. Before I do that though, I want to isolate my output value. I want to isolate the y, so I'm going to take away 8 from both sides, and I get 4x minus 8 equals y. And I'm going to make a table of values where I'm going to plug in x values to figure out what y equals. This uses that idea of independent and dependent variable. That independent variable is up to choice. So I'm going to choose what values to plug in for x. And let's just try -1, 0, 1, 2. If I plug in -1, I get 4x, or 4 times -1 minus 8. So that's -4 minus 8 is -12. When I plug in 0, well, that piece goes away, and I'm left with just -8. If I plug in 1, I get 4 times 1 is 4, minus 8 is -4. And if I plug in 2, I get 4 times 2 is 8, minus 8 is 0. Well, if I plot just those points, the section that I chose, I get something that looks like, let's see, you got something way down here. My line looks something like this as a sketch here. But I should know that. If I look at this here, I see that y equals mx plus b format of a linear equation where I can see that I have my y-intercept of -8 and a slope of +4. Every time I have a linear equation, I have a function. This one here, not in the form y equals mx plus b, so it is not a function. But that y equals mx plus b is always going to be a function. This one here, the answer is yes. It passes the vertical line test. Every x value is partnered with exactly one y value. So now let's evaluate some functions. I'm using my function notation now to evaluate. If f of x equals 6x plus 7 and g of x is x squared minus 4, find each value. So the first thing I want to do is I want to know the function of -3. So what I do is everything inside this parentheses gets plugged in for x in the f function. When I do that, that becomes 6 times the quantity -3 plus 7. And then using my order of operations, I know that I need to multiply first. Last step is to add, and I get a final answer of -11. Now I'm going to do the same thing, but this time I'm using the g function. For my g function, I'm going to plug in 5. So what that turns into is every time I see x, I'm going to plug in a value of 5. 1 squared minus 4. Order of operations tells me that I need to do my exponents first, so I have a +5 times itself, which gives me 25. Take away 4, I get a final answer of 21. Now for my last practice problem, it's going to be a little more challenging, and this one actually comes straight out of the homework. This is number 18. I want the function of f of 2 and g of 2. So I'm going to combine these two functions. F of 2, well, that tells me I have, let's erase that. There we go. For my first one, I'm going to plug in 2. So I have 6 times 2 plus 7. And then I need to find the value, my lights came off. I need to find the value of g of 2. G of 2 tells me the quantity 2 squared minus 4. Order of operations tells me that I need to deal with this exponent first before I do anything else. So I'm going to leave that 6 times 2 alone, plus 7. And I know that 2 squared, +2 times +2, gives me 4. Next step is to multiply. So I see 6 times 2, which I know is 12, plus 7, plus 4, minus 4. Which gives me a final answer of 19. Now when I'm substituting in my values, anything that's inside my function notation gets plugged in for x. I could have, and you will on number 18, you have something like g of, I don't remember, a, I think, plus 9. Well, that means that when I'm plugging in, I only plug in that a for x. So I get x, or a, quantity squared, minus 4. And then I can't forget about this piece is on the outside of my function notation. So then this drops down as the outside here. I'm not going to finish it up for you, but that gives you a good start. I think that's number 15 in your homework. So now that we've done all that, it is time to get started on the homework assignment. Homework assignment is out of your textbook on page 51, 3 through 48, multiples of 3, so 3, 6, 9, 12, 15, 18, and onwards. And then I added on number 54, 58, and 63. As you're going through this, each question is going to be worth 1 point except number 9, number, I think, 45, and 54. Those ones that have multiple parts are worth more than 1 point. Go ahead and get this done and make sure you self-correct and submit your form on Teams. Thanks, guys.